So, you're out for a stroll enjoying the lovely weather when suddenly... farewell to the last of your phone battery. No more Pokemon Go for you, I'm afraid. Thankfully I have a solution. This is Azel's TV. Let's make something. Now then. This is the battery I'm going to be using. It's from my old tablet, which suffered a monumental failure when it fell 3 inches onto my metal bed frame, and the screen basically exploded, and the case was already cracked and it wasn't really working properly, and it was beyond economic repair, so I saved the battery out of it. And I'm going to see if this works later on, because the connection to it is quite small, so we'll give that a go soon. I'm going to use this from Adafruit. This is the, what is this called? The Power Boost 500. It takes in the 5V to charge it through here, the LiPo attaches to here, and it gives out 5V into USB here, and I even supply a little plug for you. But I'm going to mount a plug separately inside the case, so it'll be like something like this. That'll go there, that'll go up there maybe, I don't know yet. I'll see how it goes. We've got to see if this works first of all. I'll give you a close up of this and I'll show you what I mean. Here's that connector compared to the size of a pencil tip. You can see how small it is. These are the contacts here and on this side here, which I need to solder to. The 2 middle connectors are for the thermistor, which is inside this battery, and it measures the temperature of the battery so that it charges properly and doesn't explode and do all sorts of exciting things like that. So first thing is to get this connector off, solder some leads onto here, and then connect that to the boost circuit. I've used my pick to break apart the connector because I realised it was going to be far too small and fiddly to desolder. It probably uses silver solder anyway, and that's quite difficult to desolder if you don't get it hot enough, and if you get it too hot it's going to just break apart the foil. Here's the 2 connectors I'm going to have to solder to. That's going to be fiddly enough, but I'll do that outside where it's a lot lighter, because it's a lovely sunny day. Back in a minute. Here we are after much soldering. That was quite fiddly getting on those terminals, but it works. I've put leads on that are far longer than what I need. It's just to test it when it's in the enclosure, which I'll make next. I can shorten the leads as I need. I've got an enable switch which turns that on, and that works good. So that turns on the output and it turns on the booster circuit and everything else for the 5V to charge stuff. Now let's see if it'll actually charge something. I've just tacked this on very delicately for now, because the socket won't be on the final product, at least not on the board directly. Let's plug this in. And now haha, it works. It's working. Excellent. Right, now I'm going to take it outside and charge it, and hopefully the battery won't do anything too exciting. It should be okay, because it's a standard 3.8, what is it, 3.8 volts DC LiPo. But just to be sure, because it's not really, it's not a hobby grade battery, if you like, for lack of a better term, but we'll see. Right, if all goes well, I should have a light somewhere on here which will illuminate when this starts charging. Here it is, orange light. I believe that goes green when it's fully charged. We'll come back in about an hour or so and see how it goes. I mean, I think it was fully charged when the tablet broke, so the battery should be still okay. It wasn't that long ago, so it wouldn't self-discharge in that time. It was less than a month ago, so we'll see. I bought this indoors because it was still cool outside. I mean, the battery pack hadn't gotten hot at all. It was doing completely fine, but it's still not charged. And I wonder if the cell voltage is slightly higher, because I think it says 3.8 on here, but I think standard LiPo batteries are 3.7, so this fully charged light may never go out. I don't know, I guess we'll have to see. Also, the battery on the camera is about to run out, so that's fun. Oh good. But I'm going to leave it on and see if it gets charged, and then I'll see if I can charge a phone with it afterwards, see if we'll get it fully charged, hopefully. So, let's leave on for a few more hours. It is green! Finally! It's taken, I don't know, hours and hours. I think my problem is using the really wimpy charger. I mean, I've got the weakest charger in my possession. I don't know why I use that. I'll just grab the charger at random. So it's taken ages to charge up, but it works. Okay, so next is going to be charging up a cell phone and seeing how long that takes and if that works and everything else. It's finished charging the phone. That's fully charged now, brilliant. That took about an hour and a half to charge from 50%. So now I'm charging the tablet, and I'm going to see how long that takes to charge. Still got power. The low battery light hasn't come on yet, so we'll see how that goes. It's very cool to the touch. It gets to about room temperature-ish, slightly above, probably a degree or two above, but that's it. So fantastic, really pleased with that so far. Right, let's check back in later on. Okay, this charged the tablet most of the way. It got to 90%, which isn't too bad, so we'll charge it up again. The battery will charge up again tomorrow and give it further testing, but I think that's working good. Really pleased with that. After much more soldering, we have this design. What I've done, I've actually extended the charge socket, the USB charger, to an external one. Instead of extending the output, I've extended the input socket instead, because it was easy. I mean, I have this already mounted on a PCB, so that's handy. I don't have one of these mounted on a PCB, so I've left this one on the circuit itself, extended these wires across, and I have this going to this switch here, and these leads under here going to the battery terminals, and it works really well. So if I turn this on, that lights up as normal. Turn it off and it turns everything off again, and that works nice. So next step is to make a case for this to go in. So luckily it's only slightly larger than the battery itself, so it'll fit in quite nicely, have a very low profile. And here is the case this fits in. I've got all sorts of recesses and support parts and everything else going on. I've got a notch cut out for the switch that goes in there. This took a long time. I just sat carving this out and gluing bits and cutting bits while I was watching YouTube on the laptop. And that fits in there like that. It's very relaxing to sit and just building up slowly but surely. Right, I've got these parts here. Now what I'm going to do, these are going to glue on the lid itself, so the lid goes down on that like that, and I can unscrew it and take all apart if I need to. So these go on like this, and it will just slots and just rest together for the time being. That goes on like that. So it all slots together and looks good. Now I could glue that together like that and call it done. I mean, it all works fine. There's screws in the side there that engage with the switch. At the moment it's just loose. but they screw and hold it together. I could just leave it like that and call it finished, but I've actually got an idea for a little window to go up here so I can see the electronics inside it. And I've also got an idea for extra functionality, but it's going to take a while to amass parts. So I'm going to leave that until next week. So this is going to be a 2-part episode. So tune in next week. We'll carry on with this, and we'll see what I have planned. Thanks for watching. Stay tuned.